The extent of a reaction in any chemical process may be limited by the amount of one of the reactants. That reactant is called the limiting reagent. For example, zinc metal reacts with hydrochloric acid to form zinc chloride and a hydrogen gas. When 2.5 times 10 to the negative third moles of zinc is reacted with exactly twice as many moles of hydrochloric acid, the metal will react with the acid to yield both zinc chloride and 61 milliliters of hydrogen gas. This apparatus will enable us to demonstrate the concept of limiting reagents. The amount of gas evolved is measured in a gas burette. The round flask is moved up and down as needed to match the levels inside and outside, thus maintaining constant atmospheric pressure. When the zinc metal is added to the acid solution, it reacts, liberating hydrogen gas. This hydrogen gas is then collected in the gas burette, which is balanced by the leveling bulb. When all of the zinc has reacted, the amount of hydrogen gas generated is 61 milliliters. When we use only half as much zinc, this time only 82 milligrams with the same amount of hydrochloric acid as before, the metal will react with the acid to yield 30.5 milliliters of hydrogen gas. Because we have used half of the stoichiometric amount, all of the zinc is consumed in the reaction, and as predicted, the hydrogen gas in the gas burette is 30.5 milliliters, or half the previous amount. In this case, zinc is the limiting reagent. This last experiment begins with 200 milligrams of zinc, an excess of metal. At the completion of the reaction, unreacted zinc remains in the flask. The same amount of hydrogen gas was generated as in the first experiment, 61 milliliters. The reaction came to a halt when all the hydrochloric acid was consumed. In this case, HCl was the limiting reagent.